Okay, I wanted to do a recording of a review session for oligopoly and game theory. Okay, so oligopoly is a situation where you have a few firms, and if it's two firms, we call that a duopoly. Okay, now realize that in an oligopoly, so duopoly is a type of oligopoly with only two firms. Okay. You can have an oligopoly where everybody's selling an identical good. You can also have an oligopoly where they're selling a differentiated good. So just because it's a differentiated good does not mean it's not an oligopoly. It could also be where they're selling an identical good. What I went over in class is specifically the case where they're selling the identical good because it's much easier to get a handle on. Okay, so you can have like 4 or 5 players in the market, but we're going to focus on the duopoly case because it's much easier to analyze a case where you only have 2 players. Okay, so we're going to focus on the duopoly where everybody's selling an identical good. Okay, and since they're selling an identical good, okay, so for that good, okay, we know there is a certain demand curve. This is the demand curve for the good. Okay, and so what happens is if there is 2 players, let's say there's John and there's Mary. Okay, if John produces 50 units and Mary produces 100 units, what's going to be the price? Okay, so the total quantity will be 150. So then you say, okay, 150 is here. The price is going to end up being $5. Okay? If John produces 100 and Mary produces 150, then the total quantity is 250. At 250, the price is going to go down. Let's say the price is going to become $3. So the idea is that whatever quantity the 2 players choose, we add up that quantity, we have the total quantity, and that will determine the price. Okay, so when the total quantity was 150, the price was 5. When the quantity was 250, the price went down to 3. So whatever Mary does, whatever Mary chooses, what quantity Mary chooses will affect the price. Whatever quantity John chooses will affect the price. So Mary's actions affect the price, and so do John's actions. And of course, whatever the price is affects the profits of each one. So the fact is that each one, their actions will affect not only their own profits, but the profits of the other guy also. And that's the concept we refer to as interdependence. Okay? That the outcome for each player is interdependent on what the other guy does. Okay? So now let's assume that you have these 2 players. What are they going to do about it? Okay? So we said one possibility is that for these players is that they're going to form a cartel. Okay? Another word for a cartel is a trust. Okay? And we said that cartels are illegal, so that's what we have antitrust laws for. Antitrust laws prevent oligopolies from forming a monopoly. So they're there to make sure that there's competition in the market. Okay? All right. So when they form a cartel, so basically they say, okay, instead of fighting with each other, we're just going to choose the profit maximizing outcome for a monopoly. In other words, they put down the marginal revenue, the marginal cost. So they will choose this quantity, this price, and then they split the profits amongst themselves. So this is the monopoly outcome. Okay? Let's say, okay, let's say that we have John and Mary, okay? So we got John and Mary, okay? And let's say that the quantity that maximizes profits is 100 units and the price ends up being $5, okay? So let's say they agree that they're going to split the market 50-50. So John is supposed to produce 50, Mary is supposed to produce 50, and as a result, the price will be $5, okay? Because the quantity in total is 100, okay? And incidentally, let's assume, okay, that the average, let's say that, you know what, I'll make this simpler. Okay. We're going to say the marginal cost is equal to the average total cost is equal to 2. Okay? It's a constant marginal cost, constant average cost. So how much profit do each of them make when they are forming the cartel? So when they stick to the agreement that each of them produces 50 units, how much profits do they make? So let's actually put profit for Mary and profit for John. Okay, so John is producing 50 units. The price is 5. His cost is 2 per unit. So John is getting $3 worth of profit times, so 5 minus 2, that's $3 worth of profit, times 50 units that he's producing, okay? So that's $150 worth of profit. And Mary also, okay, 5 minus 2 times 50, she makes $150, okay? So they're each making $150. Now, suppose that Mary thinks she wants to cheat, okay? If Mary produces 10 more units, but John doesn't realize she's going to cheat, so he's still producing 50, but Mary is now going to produce 60. So the total quantity that hits the market is actually 110, okay? Unfortunately, at 110, the price is going to be lower. The price is going to be $4, okay? So the price is going to be $4. So now, how much money does John make? John is still producing 50, okay? But the price he's getting is now $4, okay? So he's going to make $4 price minus his cost times 50, okay? So that's 2 times 50. He's going to make $100 in profit. So his profit went down when Mary cheated on the agreement. What about Mary? Mary is going to make 4 minus 2, but she is producing 60, okay? So she makes 120, okay? So this is a situation where she would not end up cheating, okay? Because it doesn't pay for her to cheat, okay? Let me tweak this a little bit. Let's say, so I have to change, because in reality, sometimes it pays to cheat, sometimes it doesn't. So let's rewind a little bit. Let's say that she produces 100 units, okay? And at, so now the quantity that hits the market is 150, and at 150 the price is 4, okay? So again, John is making $100 in profit because $4 is the price they end up getting, minus 2 times 50. But Mary, okay, gets 4 minus 2 times 100, okay? She makes $200, okay? So forget what I had said before. What I wanted to illustrate was a situation where by cheating, she makes more money, but he ends up getting hurt, okay? This is typically the situation we show to illustrate that cartels are difficult to maintain because there's an incentive for the participants to cheat, okay? But as you know, I inadvertently ended up showing you, it's not always the case. Like there are certain there is a point where it does not pay to cheat. So you have to actually do the numbers to figure out whether your profit is higher by cheating or not. Okay? All right. So that's one possibility that you could do if you're an oligopoly. You could form a cartel or a trust and make more money, assuming that you're able to maintain the cartel and nobody cheats. Okay? The other thing you could do as an oligopoly is you could compete with each other. And when you're competing with each other, we mentioned two types of oligopolistic competition. Bertrand competition is where you're competing on price. Okay, Cournot competition is where you're competing on quantity. Okay, so you just need to know this in terms of knowing the terminology. Okay, but we're not spending any time on it. Okay, what we are going to spend time on is the concept of game theory. Game theory is where you write down your different possible strategies and your opponent's different strategies, and you try to work out whether there's a strategy that is the best for you, given for everything your opponent does, what's best for you. Okay, so I'm going to pull up here an example from the AP exam. This is the 2009 AP Form B. You have two interdependent bus companies. So again, interdependent because what each one does affects the other. One is called City Wheels, one is called Easy Ride. They both provide transportation services in the same city. Following a change in costs that affects both companies, each company must decide whether to lower its fare or maintain its current fare. In the payoff matrix below, okay, the first entry in each cell indicates the daily profit to Easy Ride, and the second entry indicates the daily profit to City Wheels. So you got Easy Ride and City Wheels. They each have two choices, to either maintain the fare or to lower the fare. Maintain the fare or to lower the fare. And the way you can read this payoff matrix is if Easy Ride maintains the fare and City Wheels maintains the fare, Easy Ride makes 150, City Wheels makes 180. If Easy Ride maintains the fare and City Wheels lowers the fare, Easy Ride makes 130, City Wheels makes 120. If Easy Ride lowers the fare while City Wheels maintains the fare, Easy Ride makes 120, City Wheels makes 130. And finally, if Easy Ride lowers the fare and City Wheels lowers the fare, Easy Ride makes 140, lower fare makes 110. That's how you read the payoff matrix, okay? What I like to do is I like to draw it in different colors because that really does help to see it, okay? So we're going to put the payoff matrix, and that's part of the reason why we always look at a duopoly. It's much easier to draw a 2x2 payoff matrix, okay? So let me do Easy Ride in red, okay? And its payoff is the first number in the cell. And we're going to do City Wheels in blue. So the second number in each cell corresponds to the profit for City Wheels for that particular strategy. Okay, so maintain fare, lower the fare, maintain, and lower the fare. Okay? All right. Now, the way we're going to solve this is we're going to say City Wheels. We start out with City Wheels. With Easy Ride. Easy Ride is going to say, if City Wheels maintains the price, so if my opponent maintains his price, what is my best response? If City Wheels maintains his price and I maintain my price, I would make 150. If City Wheels maintains his price and I lower my price, I make 120. So which do I prefer, 150 or 120? I prefer 150. So again, we said if City Wheels maintains his price, my best response is to maintain my price. If City Wheels lowers his price, what's my best response? If I maintain my price, I make 130. If I lower my price, I make 140. So it's best for me, my best response in that case would be to lower my price. Okay? So we put an underscore on whichever is the best strategy for Easy Ride for each possible strategy that City Wheels does. Okay, so again, if City Wheels maintains price, it's best for Easy Ride to maintain price. If City Wheels lowers price, it's best for Easy Ride to lower price. Now let's look at City Wheels. Okay, City Wheels says if Easy Ride maintains price, so I'm looking at this row. If Easy Ride maintains price, then if City Wheels maintains price also, they would make 180. If they lower price, they would make 120. Which they prefer? They prefer 180 over 120. So 180, maintaining the price, is their best response if Easy Ride maintains price. If Easy Ride lowers the price, what should they do? Should they maintain price and make 130 or lower price and make 110? 130 is more than 110, so they should maintain price. So you see for City Wheels, okay, regardless what Easy Ride does, maintaining price is their dominant strategy. So a dominant strategy, okay, is a strategy that does not change depending what the other guy does. In this particular case, you see, regardless what Easy Ride does, City Wheels' best response is to always maintain price. So maintaining price is a dominant strategy for City Wheels. For Easy Ride, does not have a dominant strategy, because you see Easy Ride, it pays for them to maintain price if City Wheels maintains price, but it pays for them to lower price if City Wheels lowers price. So their strategy changes depending what City Wheels is planning to do. But City Wheels, their strategy is to always maintain price regardless of whether Easy Ride maintains or lowers the price. Okay? So what we've done is we've drawn an underscore on the best response for each player. And what we do is then we identify which cell has both entries underlined. And guess what we call that? We call that the Nash equilibrium. So the Nash equilibrium, okay, is a situation where both are playing their best response. And so the reason it's called an equilibrium is that if you're in this situation, there's no incentive for anybody to change their response, because already this is their best response for what the other guy is doing. So they're both doing their best response. Okay? And so in this case, you have one Nash equilibrium. Okay? So looking at this particular question, the way it was asked, if Easy Ride chooses to maintain its current fare, which strategy is better for City Wheels? Maintaining the fare. Why? Because 180 is more than 120. Is there a dominant strategy for Easy Ride? We said no, because Easy Ride has a different strategy depending on what City Wheels does. Assume that the companies must make their decisions simultaneously and they do not cooperate. In other words, they do not form a cartel. What will be the daily profit for each firm? So if they do not cooperate, that means that they're playing this game, and the Nash equilibrium is for both to maintain fare. That's going to be the profit. Okay? If these two firms could cooperate, which strategy would each firm choose? So in other words, what we have here is that if they cannot cooperate, they're playing this game and they're finding the Nash equilibrium, which is for both of them to maintain fare. And so their combined profit is how much? It's 330. 150 plus 180 is 330. Okay? Could they do better if they cooperated? Okay? If they cooperated, let's see. is this more? 140 plus 110 is 250. This is 250. This is 250. So actually, this is the best that they could achieve. Okay? If they could cooperate, they still would choose to maintain the fair. That's not always the case, by the way, right? Sometimes in many games, what you have is that the cooperative equilibrium, or in other words, if they cooperate and choose the highest monopoly profits, the highest combined profit, you end up with a different outcome than the Nash equilibrium. But that's only achievable if you cooperate. Okay? Suppose that the local government decides to provide a subsidy of $40 a day, okay, to the bus companies. However, only a company that agrees to lower its fare is eligible to receive the subsidy. Draw a new payoff matrix to reflect the change in government policy. So in this case, you're saying, we're going to change the payoffs to say that the government gives you $40. A subsidy is money from the government. They give you $40 if you lower your fare. Okay, so in other words, we would have to change the, hold on a sec. We would have to change the outcomes so that whoever lowers the fare, okay, gets an extra $40. Okay, so this is profit, right? So in this case, this cell, okay, Easy Ride maintains price, so they don't make the extra money, but City Wheels lowers the price. So instead of 120, City Wheels would get 160. Here, instead of 110, City Wheels would get 150. And what about the other one? Hold on a sec. This cell is not affected because they're both maintaining price. This cell, the red guy, is lowering the price, so he would get 160. And here, he would get 180. Okay? So let's see if we end up with a different outcome. Okay, so okay, hold on a sec. Let's rewrite this. So this was 150. That's not affected. And this was 180. This is 130, 160. Okay? And let's see what Easy Ride would do with these new numbers. So Easy Ride says, if City Wheels maintains the price, what should Easy Ride do? Maintain or lower? Lower. If City Wheels lowers the price, what should Easy Ride do? Maintain or lower? Lower. So now, lowering the price becomes a dominant strategy for Easy Ride. Let's see what City Wheels does. City Wheels says, if Easy Ride maintains the price, they would be better off maintaining the price. If Easy Ride lowers the price, they would actually be better off lowering the price. So now City Wheels no longer has a dominant strategy, okay? And the Nash equilibrium is different now. Now the Nash equilibrium is that they both lower the price, okay? Because with the subsidy from the government, they both make more money lowering the price, okay? So this is the new payoff matrix, okay? So that's how we solve these games, okay? You could look in the previous AP exams, look for other, this was 2009 Form B. So you can look through all the previous exams to find more examples of game theory and how to solve it. But the terms that you should be comfortable with is dominant strategy, Nash equilibrium, payoff matrix, okay? Yeah, that's basically the ideas you have to, oh, and cooperative equilibrium. Oh, the last thing I wanted to point out is this concept of a prisoner's dilemma. Okay, so A prisoner's dilemma is a game where, let's say there's a bank robbery, you see two guys running away from the bank, you're not sure if they're the ones who robbed the bank, okay? So you take them back for questioning and you put them in separate rooms, okay? And you tell each one, okay, so here's the payoff matrix for the two prisoners, okay? So, we're going to call them Joe and Jack, okay? So confess, don't confess. Confess, don't confess. Okay, and Jack is in red, okay, and Joe is in blue, and in red. So if they both confess, they both get, 5 years in jail. Okay, if they both do not confess, okay, they get them on some kind of technicality, okay, where, they only have to serve a year, okay, because maybe they cursed out the cop or something, whatever, okay, so they still, but it's a much less, like, in other words, if they don't confess, they'd be better off than if they confessed, okay, but the investigators tell them, listen, they tell Jack, if you confess and your buddy doesn't confess, you go home and your buddy stinks for him, okay? We throw the book at him, okay? But realize, same thing is happening with Joe. They're telling him, if you confess and Jack does not confess, you get to go home. Oh, oops. Your buddy gets stuck in the slammer and you go home, okay? So what's going to happen? This is what we call a prisoner's dilemma. Okay, so let's see what these two guys do, okay? So let's start with Jack. Jack is going to say, if Joe confesses, what should Jack do? Should he confess and get 5 years or not confess and get 10? So confess. If Joe does not confess, should he confess or should he not confess? 0 is better than -1. So you see that for Jack, the dominant strategy is to always confess, regardless what Joe does. What about Joe? Joe says, if Jack confesses, I'd be better off confessing, because -5 is better than -10. If Jack does not confess, I'd be better off confessing. So for Joe also, the dominant strategy is to confess. As a result, the Nash equilibrium is there where they both confess, and they both get 5 years in jail. Notice, if they could cooperate, if they could be in the same room and talk to each other, they would clearly choose to not confess, right? Not confessing is the cooperative equilibrium. But since there's always an incentive to cheat, right? Because if they formed a cartel, let's say, right? So they would not confess. But there's always that possibility that one of them says, forget it, I don't want to even be in the jail for 1 year. I'll confess, and I don't care what happens to my buddy. You see? So that's what we mean by a prisoner's dilemma. A prisoner's dilemma is a situation where the cooperative equilibrium is clearly better for the players, but they can't, that's not an equilibrium because there's always an incentive for one of them to cheat, and so they end up at an inferior equilibrium because they can't make the good equilibrium stick. That's what we refer to as a prisoner's dilemma. Okay, that's it. That's all I wanted to go over. I hope you find this helpful. Come prepared for the test tomorrow.